This week, we're going to be at BSDCan, of course, ganging up on people and forcing them to give us interviews, so expect to see some of those in the upcoming weeks. Assuming we don't get arrested for harassment and left in a cold, dark jail cell somewhere in Canada, we will be back next week with your regularly scheduled programming. For now, we've got a bunch of feedback email to catch up on, as well as a pre-recorded talk that Matt Ahrens gave about ZFS back at Asia BSDCon. So we'll be back to tell you all about the conference next week on BSD Now, the place to be, SD. Episode 37, BSDCanned Goods, recorded May 14th, 2014. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And we're glad to have you guys with us this week. While you're here, we are not. We're in Canada, so of course we got a cool, awesome, pre-recorded, I guess, not really an interview, a presentation that Matt Ahrens gave in Tokyo. So we're going to be playing that here in a little bit, and it's long. I think you said it was 2 hours,
It's
Alan?
about 100 minutes, so yeah, it's a really good interview. Not interview, yes. It's from the FreeBSD
presentation.
Yeah, it's the FreeBSD Developer Summit in Tokyo at Asia BSDCon, and it was just him kind of overviewing everything they've done in ZFS in about the last 6 or 8 months and what they're planning to do in the next 6 months, and answering a bunch of our questions about stuff. It was quite a few big people in the room on top of Matt Ahrens, Martin Matruska, who's ported. It's partly responsible for keeping ZFS up to date on FreeBSD.
Kind of a who's who of ZFS on FreeBSD.
Yeah, and just other people. So there was a lot of really good questions and a lot of really good explanations on how stuff works and some of the interesting features that are coming up and all that kind of stuff. It's really good. Cool. I'm looking forward to listening to it a couple more times.
Definitely. Well, you can't mess this one. Coming from the man himself. Exactly. I mean, if anybody's going to tell you about ZFS, it should be Matt Ahrens.
Exactly. I've got a little spoiled. When I was at Linux Fest Northwest, I went to a ZFS talk and I was like, this is all just simple stuff. Where's the nitty-gritty stuff?
I want to know.
Every time I go to a ZFS talk nowadays, it's Matt Ahrens like filling my brain with awesomeness. And
it's like the introduction stuff was so 8 years ago.
And it's like what?
I want to know more.
Yeah, exactly.
But cool. But before we get to that presentation, we want to mention our new sponsor that we introduced last week, the good folks over at Tarsnap, Colin, who runs that. And of course, what does that do for you? Well, if you remember last week, if you were with us, we talked about RAID. And while that's a great thing, offsite backups are also very, very, very important and essential. So Tarsnap's going to allow you to do that. And of course, we have a website address for that, tarsnap.com/BSD Now, where you can go take a look at the service, sign up, let them know that we sent you. So what's some of the nitty gritty on it though, Alan? Why would you choose Tarsnap over something else?
Like every good Unix tool, it was invented to scratch an itch. Colin, being the FreeBSD security officer at the time, travels a lot and has a lot of very, very sensitive files on his computers that he can't afford to lose or to let anyone else have access to. So he was like, well, I need a backup solution. It's got to work even though I'm on the road all the time with my laptop, and it needs to be secure. So he kind of built Tarsnap, and then he was like, well, I suppose other people probably want this too. And so he turned it into a business. And it's online backups for the truly paranoid. So it runs on BSD, Linux, OS X, Minix, Open Indiana, Cygwin, whatever you want to run it on. And basically has a tar-like interface where you basically make a tar of all the files you want to back up. It then compares that to the previous backup if you have one, and only sends the differences to save you uploading all of your data every time. Because especially when you're on the road, you basically pay 25 cents per gigabyte per month for the storage and 25 cents a gigabyte for the bandwidth, and your files are backed up. The important things are that the files are encrypted with a key on your system. Only you ever have the key. You're responsible for not losing the key. And because Tarsnap has no way to get the key back for you. Which is
you can't email Colin and be like, I forgot my key. No, that wouldn't be secure.
Exactly. The whole point is that you're the only person with the key, and no one can access your files.
Including Colin. Who runs the service. And
one of the other things you get with Tarsnap that you don't get anywhere else is that the client you're able to view the source code, download the source code, and compile it yourself if you want, so that you're you know every line of code that's happening in the client.
Yep.
Because what's the point of a super secure remote backup client if you don't actually know that it's not sending a second copy of your files to the NSA?
That's right.
And
one
of the other interesting things is it doesn't use OpenSSL. It uses Colin's own S-tunnel, or not S-tunnel, sorry, S-pipe, which basically does the same encryption as SSL or TLS, but without some of the other stuff. And because it's basically, it gets rid of all the complexity and just does the basic RSA encryption. And because of that, it wasn't vulnerable to Heartbleed and is a lot simpler.
Cool. So again, that website, tarsnap.com/BSD Now. Go check it out. Let them know we sent you.
And the best thing is there's no monthly minimum. So you just pay for the amount of storage that you use.
I like that. Well, very slick. Cool. We'll be back just a moment with our presentation from Matthew Aaron's talk at Asia BSDCon.
I don't really have a lot of stuff prepared. I thought I could just talk about kind of some recent changes that we've been making and plans for the future, and maybe go into a little bit more detail about one or two features just to give you a flavor of like what kinds of things we need to think about for especially for like on-disk compatibility concerns. So here's some recent new features that we've been working on at Delphix. Oh, by the way, for those of you that don't know me, I'm Matt Aarons. I work at Delphix. I created ZFS back at Sun Microsystems in 2001, and I created the OpenZFS project. I'm giving a talk tomorrow at the main conference that kind of has more background info about ZFS and OpenZFS and what it is. Hopefully, most of you are kind of familiar with that. So I wanted to talk more about like some implementation stuff today. So here's some new stuff that we've developed at Delphix recently. So the most recent cool thing that I think you guys probably haven't heard of is zero-block compression, which uses a feature called embedded block pointers. The idea here is that we saw at Delphix, so at Delphix we do database virtualization, so we're storing like Oracle databases, Microsoft SQL Server databases, Postgres databases on top of ZFS, and then serving them out to over NFS or iSCSI to client computers. So one interesting thing about the way Oracle uses files is that as soon as you create an Oracle file, it goes and initializes every block by writing a little like header and footer on every block that just says like, I'm an Oracle block, I'm part of database ID whatever, I'm block number 35. The next one, all the same stuff, I'm block number 36. It's like, great. Well, with ZFS, we use compression, which is great. So we have this 8K block, and we can compress it down to 512 bytes. We saved a lot of space, but we still have to write that 512 byte block out and then read it back in. So there's still a fair amount of I/O entailed with creating these files, these Oracle files. So we figured, well, there's really very little data in there. What if we could just store that data in the actual block pointer itself? So, find it. So, in ZFS, everything is like a tree of blocks, and the blocks point to other blocks that eventually point to your actual data. And this is indirect blocks. Etc. So it's great when this data compresses down from 8K down to 512 bytes, but it's still a different block that we have to read or write. So with the changes that I've made, basically instead of, if a block compresses really well, instead of putting the data down here, we'll actually compress the data and put it in the block pointer itself. So this is like, if it compresses down to less than about 100 bytes, Then we can put it in the block. Oops. Sorry. Okay. Yeah, then we can put it in the block pointer. So now when Oracle initializes these files, it still has to send all the data over the network to us, but instead of storing 512 bytes down here, so if you look at like each indirect block, there's actually 128 pointers here. So before you'd write an indirect block and 128 512 byte blocks. Now you just write the indirect block, which is like 16K, and then it can be self-compressed. So it's a lot less I/O to do, and this is kind of the original use case for it. But we've seen that it actually there's a lot of blocks that can compress down this way. So, for example, in your typical like directory structure, most directories have just a very few number of entries. And so they can actually be compressed down and fit into this embedded block pointer as well. So things like traversing a whole directory hierarchy, there's just a lot less blocks that need to be read there, so it gets faster. There's also a lot of other pieces of metadata.
Is there like a target number of how big a directory can be while it still fits? So you should try to keep fewer than so many files in a directory so that it fits there?
I don't know that's... I wouldn't necessarily kind of look at that and then make a decision based on it, because like if you have it, you're going to have those entries somewhere, right? And creating like a whole, creating a tree with more directories, you're just going to end up with like more metadata here versus having one big directory. Like, it should work pretty well. And in general, I don't think that we want to recommend that people like change the way that they're doing their directory layout to fit this. It's more like whatever your directory layout is, we're going to do a good job of representing it. Right. So even if you have like 1 million entries in a directory, we use like on-disk hash table. So lookups are still a constant time. Or if you want to like create a big tree with lots and lots of different directories, now, we've improved the performance of that as well.
When I'm doing an NUX cache, I can adjust it to be wider or deeper.
Yeah.
One that works better now, maybe?
I'm not really sure. I think that with those kinds of things, you have to do some experimentation to see if it even matters, and if so, which is better. Since it's about 100 bytes, you can kind of think of like, okay, well, how long are my directory names? If I can concatenate all the directory names and it's like less than 100 bytes, then it's probably will be able to compress down and fit in here. Other questions? This is pretty cool. It applies to all the data in the whole storage pool. So like metadata that's in the meta object set, that can, a lot of that is also small blocks because they're like small zap objects. And so we get to use a lot of embedded block pointers there, speeding up things like ZFS list, things like that, where there's a lot of different objects it has to look at, but most of them are very, very small. This is new on-disk. So obviously this changes the on-disk format. We use ZFS feature flags to track that change. So once you enable this feature, it's just on forever because there's so many little blocks that could use it. It is a big pain to keep track of like all of those blocks. So we just say once you turn it on, it's going to be used all over the pool. So, all right. We've done, so I would say most of the things that I'm going to mention here are related to performance. That's mainly what we've been focusing on. So obviously this improves performance as well as space utilization. We ran into another problem where if you're doing like a ZFS list or like ZFS get all, especially if you have lots of snapshots of zvols, we saw that this operation was really, really slow. And the reason that it's so slow is actually because we're reading the same data off disk again and again and again, which is not supposed to happen because we're supposed to cache it in the arc. So if you think of like a ZVol or any file system, typically all of its snapshots share a lot of the data with it. So when we're getting the properties of a file system or snapshot, there are some properties actually stored inside the file system. So for example, for ZVols, you can think of there's like two places that its properties are stored. One is the kind of generic properties, like say compression or checksum, quota. Those are all stored kind of at the generic property level in the meta object set. But then there's also ZVol specific properties like the size of the ZVol and the ZVol block size. So those properties are like part of the snapshot. So for example, if you change the size of a ZVol and then take a snapshot, then old snapshots will know about the old size and new snapshots know about the new size. But generally, if you aren't changing that, then this property information that's stored in the ZVol, it's all like the same blocks that are referenced from every snapshot. The problem is that so the question is like, why are we rereading these blocks that give us the ZVol property information over and over again when we're getting the size of each snapshot? The problem is that when the ZVol, when that snapshot is closed for the last time, we explicitly go and evict all of its data from the arc. So what happens is like you open the snapshot to go get the property, you get the property, you read in all the, these, maybe it's like 5 or 6 blocks off of disk that we need to get that information. Then we close the snapshot, evict all that stuff from the arc, open the next snapshot, it references all the same blocks, so we got to go read them all off disk again because we threw the data out of the cache. Normally, this isn't a problem because like you tend to have everything mounted all the time. So like all of your file systems are always mounted. So when you open the file system, it's like it's already like open. So when we get the properties for it, it isn't the first open and it isn't the last close. So we have to keep caching everything because it's already mounted. It's mounted during that whole time. But for ZVols, this isn't always the case because unless you have it actually exported over iSCSI or like a file system mounted on top of it, we don't keep the ZVol open. There isn't the same concept of mounting it the way that there is with file systems. And we're making some changes in that area, but we still have this problem. So basically, I changed the code so that when the object set is closed, we don't actually go and explicitly evict everything from the arc. This is kind of happening by accident because when the object set is closed, we're basically tearing down all the information at the DMU level. So all the debuffs, all the denodes. And kind of as a side effect of that, we were also tearing down the information in the arc. So basically, I was able to like decouple that so that we can get rid of all the DMU level information without having to evict the stuff from the arc. And I found a couple other places that were doing similar things. So now the only times that we explicitly evict things from the arc are like when basically when you've asked for that administratively by setting the primary cache and secondary cache properties. So with those, you can say, I don't want this file system to be cached in the arc. If you've done that, then we will explicitly evict stuff from the arc when it's no longer needed. But otherwise, we just let the arcs, LRU and least recently used and least frequently used algorithms figure out when to evict stuff. Any questions about that? This is another kind of weird random thing. So we found that So both the ARC and the DMU have hash tables that they use to index all of the blocks. So like in the DMU's hash table, it's indexed by the data set, object, level, and offset, and then it tells us what debuff is associated with that. And then in the ARC, it's indexed by like which pool, which VDEV, and which offset, and then it gives us the ARC buff that's associated with that. So the interesting thing is these hash tables are statically sized. We choose how big they are when the system boots. And the debuffs hash table was sized to be able to fill all of memory with debuffs, with assuming an average like 8K block size. So that's pretty good, right? I mean, it's pretty rare that you'd use a smaller block size than 8K. Maybe use 4K, in which case you could fill all of memory with. If you filled all of memory with 4K, then you'd have like two. Each hash bucket would have two things chained in it, which is not too bad. But for the ARC, it was actually sized to fit only fill memory with 128K blocks. So if you aren't using 128K blocks, if you're using 8K blocks, then you could end up with whatever 128 divided by 8, like 32, 32 chained entries in each bucket of the hash table. So we found that this wasn't like a huge performance overhead, but it was a couple percent for cache-heavy workloads. So we increased the size of that by default, and we also made it so it's tunable. So if for some reason you needed to use 1K block sizes for everything, you could turn that variable down. Questions about that? Pretty simple. The next thing that I worked on was metadata redundancy equals most. So the default is metadata redundancy equals all. Basically what this means is that all metadata in ZFS we will store at least 2 copies of. That's how it's always been in ZFS. So like in this tree of blocks that I drew, all of the indirect blocks, we store 2 copies of it. So let me just draw this again. So we saw that I was doing some performance testing where we were doing random writes. So basically the performance test is we create a big file with a 4K or 8K block size, and we have a bunch of threads, and each thread is just randomly selecting a block ID and then writing to that block. So if you have a big enough file, then essentially every block that we modify, so let's say I modified this block, I'm going to need to write out this block, and its parent, and its parent's parent, etc., all the way up on the tree. So if the file is big enough, then I'll only have one block under each indirect that's modified. So for every block that I modify, I have to write out itself and the level 1 indirect block. And there's 2 copies of this. So like for every write that I do, I have to write out actually 3 blocks. 3 copies, right? One copy of this, and then 2 copies of the indirect block. So by setting metadata redundancy equals most, it tells us, all right, just store 1 copy of the lowest indirect block. So then instead of having to do 3 writes, we're just doing 2. So this is like a theoretical performance gain of like 33%. In practice, I've seen like about 25% performance gain on that workload.
What are the risks of not having 2 copies of the metadata?
So if this block was lost somehow, the disk didn't write it correctly, or the bit got flipped on disk, then when we read this block, then all of the blocks underneath it would be also inaccessible. So the reason that we keep redundancy of all of these metadata blocks is so that any single block being lost, it limits the amount of data that can actually be gone. So normally, if any single block in the pool is lost, then at most one single block of data is gone. With this change, if you lose this indirect block, then all the blocks underneath it would be gone. So that's up to 128 blocks. Given that the typical use case here is like you're using 4K blocks, 128 times 4K is like 4 times as big as the biggest block that we support, which is 128K. So it seemed like the total amount of data lost is still not much worse than the worst case of I have a 128K block and I lose just that one block. The tricky part of this was actually not all the stuff that I just mentioned, but we need to make sure that the really annoying thing is, let's say we did lose this indirect block. And so now we can't get at the data below it. We also don't know what their block pointers are. So we don't know, so if we decide eventually we're going to like destroy this file system or delete this file, when we destroy the file system, we have to go find all the block pointers that are part of it and free them so that the space can be reused. But if we've lost this indirect block, then we don't know where these blocks are stored on disk. So in that case, basically these blocks will be leaked. So I implemented a bunch of infrastructure to like keep track of this. So when you delete a file system, it goes and tries to traverse all this data, and if it encounters one of these indirect blocks that can't be read, then it remembers it and continues on, freeing the other stuff. And then you can see how much space was leaked in a new zpool property. So you may have seen, like, when you do a zpool destroy, when you do a ZFS destroy, it destroys that in the background, and there's a zpool property that's called freeing that tells you how much space is like we're currently working on freeing up. And now there's like a new one that says space leaked. That's how much space we couldn't find because of these broken indirect blocks. Typically, this is like this would be a very rare case. So we haven't really done much to address that leak. It's theoretically possible to, especially if you're willing to take the pool offline, we could like traverse all of the indirect blocks of the whole pool, like when we're doing a scrub, and recompute, basically find everything that's reachable, and then rewrite all of the space maps to show that that's what's allocated rather than what they've been keeping track of, to free up that leaked space. So far, we haven't really seen a need for that, just because it's pretty rare that you would get this, and the amount of space, if it's just one block that's gone, like there's very little space that's leaked.
Yeah, but make it a giant pool.
Yeah, exactly. If you have some more widespread damage, where you have a lot of these blocks that are gone, then that widespread damage is probably causing bigger problems than just some leak space. Yeah. All right, cool. Any questions about this? Yeah, go ahead.
Is that an appropriate thing for a default? I mean, as opposed to all? I recommend that for a laptop.
Mm-hmm. I don't think that it's appropriate for a default, just because of let's maximize paranoia if it doesn't cost us anything. It's really hard to see the performance improvement of this, except for in this kind of random write case where you have like a big file and you're doing random writes. Because normally, like, some typical laptop use, you're generally like, files are like write once. Like you create the file, you write the contents from beginning to end, you close it, and then that's it. Then you go back and read the file from beginning to end. There's no real random access that is typical of like laptop use. So in that case, like you write 128 blocks and then 2 more. So it's like the overhead there is very minimal. Yeah, so I don't think it's appropriate as a default. If somebody does more research and finds that like it is a substantial performance win on certain use cases where people wouldn't really be educated enough to turn this on, then, I think we could consider that.
Is that, so is this, excuse my ignorance, I mean, is this something I can turn on in FreeBSD now, or is this for later ZFS?
So all of this stuff above the already integrated line, this is all, this is only in Delphix right now. Okay. We just released the source code for this earlier this week. It's on GitHub, and we're going to be working on getting this integrated into Illumos and FreeBSD.
Okay.
So this is kind of what's coming.
This specific thing might be interesting for the FreeBSD package builders that have lots and lots of jails typing make and writing lots and lots of files over and over and over again.
Yeah, it's possible.
Okay.
Yeah. So the last thing that we've been working on is improving performance on pools that are pretty full and fragmented. So the test case we've been using for this is similar to what I just mentioned. So we basically create a pool, create one big giant file that fills up X% of the pool, and then randomly write to blocks within that file using 8K block size. So if that file is like 50% of the pool size, then performance is pretty good. If that file is like 80% of the pool size, performance is not so good. So we found that there's both fundamental limitations there as well as kind of self-imposed problems. So I mean, fundamentally, like if the pool is 80% full and the workload is totally random writes, like you're only going to be able to find so much contiguous free chunks to write to. So you're necessarily going to have to spread out the writes, over some big part of the disk. But there's also a bunch of self-imposed problems there where we were not doing the allocation very efficiently. So we were spending a lot of time trying to figure out like, oh, gee, this Metaslab doesn't look very good. It doesn't have a lot of free space. So let me go find another one. Oh, this one has a lot of free space. Great. But so I'm going to write to it. But it turns out that one has all like just tiny little bits of free space spread out throughout it. So each chunk is only, 2 kilobytes. So I have to spread my data all over that. So to combat that, we implemented fragmentation metric in histogram. So with each Metaslab, we keep track of a histogram of how many free chunks are there of each size. So that way we'll know before we start allocating from it. We will know, this. You might have 2 Metaslabs that have the same amount of free space. So say 2. So this is, if we look at the histogram, and this is chunk size, and this is count. If you have one that looks like this versus one that looks like this, these could both have the same amount of free space, but this one, it's all in very small chunks, and this one it's in just a few big chunks. So this one is much faster to allocate from. So we can now use this information when we're choosing which Metaslab to allocate from. And we also, you can, for diagnostic purposes, you can see these histograms with ZDB, but we've also aggregate this information into percent fragmented metric, which is like a little bit hand wavy. The best way to understand it is like if all the free chunks are like, I forget what it is exactly, like 1 meg or better, 1 meg or bigger, then we say it's 0% fragmented. And if all the free chunks are like 1 kilobyte or smaller, then we say that it's 100% fragmented. And then it kind of scales between that. So like 50% fragmented, I think it corresponds to like everything is in 128K chunks. So we use that percent fragmented, and we also, you can see that in zpool list. If you do like zpool list -v, where it shows all the VDEVs, it shows how much space is allocated and free on each VDEV, and also this percent fragmented metric. So this can kind of help inform you about why performance is good or bad on a given pool. So you might have like two pools, they're the same size, they have the same amount of free space, but one of them seems to perform a lot better than the other when I'm writing to it. This fragmentation metric could help you understand, oh, this one is really fragmented, that's why it's slower. Cool. Questions about that? All right. Yeah, so as I mentioned, all that stuff that I've talked about so far is kind of up. It's been implemented, but it's not in OpenZFS yet, and we're going to be working on upstreaming that in the coming months. Then there are a couple of things that are already in OpenZFS. These are all in Illumos and in FreeBSD, I'm pretty sure. So you might have already heard about them. The first one is ZFS bookmarks. So the problem that we were trying to address here, and this is a little bit different. The other ones were all pretty much performance related. This is more functionality or space usage related. So if you're doing remote replication, the typical workflow is like, all right, I have, this is time. I have a bunch of snapshots. What I want to do is take a new snapshot. So this is snapshot A, and send it to the remote system. And then as time goes on, maybe the next day, I'm going to do another incremental replication. So I create snapshot B, and then I'm going to do a send from snapshot A to snapshot B. And then once that send is completed, I can delete snapshot A. But I have to keep this snapshot B around because then the next day, I need to send from snapshot B to snapshot C. So then when that completes, I can delete snapshot B. But I always have to keep around this snapshot because this is the one that the remote system has. I need to be able to send from this time to the current time. If everything's going well and you're doing replication, say every hour, every day, then the cost of keeping the snapshot around is pretty low. But if say the link breaks, the other machine needs to have some maintenance done on it, then if this snapshot could get very old, in which case we're actually holding on to all that data. You could imagine like, oh, well, I've deleted all these snapshots, and I've deleted all these snapshots, and I'm just like way out in the future here. But I have to hold on to this really old snapshot so I can know where to send for the remote replication. ZFS bookmarks allows us to get rid of this old snapshot. So basically, we create a bookmark. I don't know how to denote this. Let's see. That's what a bookmark looks like, right? Nice. Yeah. So we create a bookmark at this time, and then we can get rid of the snapshot. So basically, we'll have like a bookmark here called B, and we can send from this point. The point of the bookmark is that it doesn't hold any of the data, so you can't like access the data from that point in time, but it remembers the information that we need to do the incremental send from it. So in particular, it's like the birth time and the GUID. The GUID is like a number that identifies the snapshot, and we use that to verify that when we receive this send stream, we use it to verify that it was being sent from the place that both sides actually agreed on. So this is obviously like a very small amount of information to keep. Any questions about this? Yeah.
So is a bookmark like it's going to keep track of, unlike a snapshot where it's like all of the state of what was going on at that time. This is more of a
It's just the point in time.
Just like right here. There's no. It's not like it's keeping a bookmark is keeping all of the changes.
No,
since then.
no. It's so just so when we do the send, like if this was a snapshot, and we're sending from snapshot B to snapshot C, then we don't. This information is the only information that we actually use about the snapshot too. When we do the send, so you can think of like there's this whole tree of blocks underneath here. The information that we need to send is so in this tree of blocks, everything has a birth time. So let's say this was time 10, and this is time 20. So we need to look at all the birth times of these blocks and see like, oh, this block was born at time 5, this time was born at time 15, this one 17, this one was at time 6. So the blocks that were born before time 10, the other side already has, so we don't need to send them. The ones that were born after are the ones that we need to send. So we don't have to look at the actual data that's in this tree, because we can know what to send based on the birth times. So basically, we save this number 10 is the birth time, and then we just compare that to each of these blocks' birth times.
Thank you.
Does that make sense?
It does. Thank you.
Do you create a bookmark, or do you convert a snapshot to a bookmark?
You create a bookmark based on a snapshot.
And then delete the snapshot?
And then delete the snapshot, yeah. So the reason we did it that way is so that the workflow could be like when I so like when I'm going to do a send, I'm going to have I'll have a bookmark. I'm going to send from the bookmark to the new snapshot. What I can do is first create a bookmark based on this time, then do the send, and then I can delete the snapshot immediately, or I can say, oh, that snapshot is just like a regular snapshot, and it'll be subject to some retention policy that all snapshots are subject to, and so it'll get deleted at some later point in time, but I don't need to worry about the fact that it is being used for this remote replication. Does that make sense? And the syntax for this is like ZFS, bookmark. I think it's like the snapshot, so like pool /fs snap, and then the name of the bookmark. The bookmark is denoted by using a pound symbol instead of the @ symbol, so then it would be like pool /fs pound. Then the typical case would be to just name it the same way, but it could have a different name. It's not a snapshot; it's a bookmark. Right. And then when you do the ZFS send, you can do like ZFS send -I pool /fs pound bookmark, and then the snapshot later. Does that make sense? Right. And you can also use the same, people might not know about this, but you can do this abbreviation where when you do ZFS send -I, you can just start with the @ or pound symbol. So if you're sending from a snapshot that's in the same file system, then it'll just figure that out. The only real need to specify the file system name here is if you're sending a clone and you want to do an incremental send from its origin, then this could be the origin, and it can also be like an earlier snapshot in the origin's history. So this can be like any snapshot from this file system's kind of clone history. Normally you wouldn't, Normally, you wouldn't go back further than its actual origin, but it's possible. There's some weird cases where you might want to do that. All right, cool. Questions about ZFS bookmarks?
Are bookmarks like a feature flag or not?
Yeah, so this changes the on-disk format, but it changes, actually that's a good question. How did I do that? Well, it changes the on-disk format, but it doesn't, I don't think, certainly you could access it read-only, even if it had bookmarks. But, you know, I may have actually done it without a feature flag because basically we're just adding these pieces of metadata. And if you went back to an older version of the software, it wouldn't know about that. But I think the worst that could happen is that when you delete a file system, like the list of bookmarks is in a different object and it wouldn't know to delete that object, so you might leak like a kilobyte of space. And I don't remember if I actually added the feature flag to prevent that, or if I just said, whatever.
I'm currently looking at our heads.
Oh yeah.
And it's already imported by Xingli, and you have added a feature flag.
I did add the feature flag. Okay. There you go. But it's read only, right? The man page should list. I think that it's read only compatible, meaning that if you go back to older
feature bookmarks is the name.
Yeah.
Of it, and which of the attributes is read only? First one, second one, third. That's
Yeah, cool. Okay, so I didn't even let you leak the kilobyte of space.
But it's not yet in stable time.
Yeah.
It should be.
Yeah. Yeah, this stuff is in head, but these changes were only integrated like in the past couple of months. So we've made some improvements to read-only pools. So this is different than read-only file systems. A read-only pool, the typical use case for this is like if you have a pool that's broken in some way and it can't be imported writable, but you can import it read-only, then you want to be able to like import that pool read-only and then do a ZFS send to get all the data off of it that it's possible to recover. Before you couldn't actually do this because ZFS send was trying to like actually make some on-disk changes to put a hold on the snapshot that you're sending so it doesn't get deleted while you're in the middle of sending it. Obviously, it can't be deleted on a read-only pool, so we just added some checks so that it doesn't do that. We also, kind of related to that, I added a flag to, not a flag, I added a tunable. So this is not like a really like a supported thing yet, but you can set a magic variable that says that when I do a ZFS send, if there's any data that can't be read off disk because it's corrupted, then do the send anyways, and it just fills those blocks with like some pattern like 0x bad block or something. The reason that I didn't make this like an actual real option is because this is not the way it should work, right? Your data should not get filled with some random pattern. What should happen is we should actually send a record in the send stream that says like the data in this range is not known. And then the receiving system should like create a block pointer that basically says like when you try to read this block pointer, just return like EIO. So that kind of the behavior that we had on the sending system is preserved on the receiving system. But nobody has needed it bad enough to actually implement that yet. Yeah, there were a couple of other like minor improvements to read-only pools, but that was the main one. Any questions about that? All right, so the last one is whole birth time and some other performance improvements to ZFS send. This was integrated a while back. I think this might be in 10 stable now. The idea here is that when you do a ZFS send, I'll draw my little diagram again so that to illustrate this. So when you do an incremental ZFS send, we might be sending from the last one's at 10, this one is at 20. So we have birth times at 5, 7, 15, 18. Maybe you could go backwards if they were writing it in a different, if they're doing random writes. There could also be some data that was never written, right? So you could have a sparse file. The common case and the case where we saw this causing performance problem is like a zvol. So like you create a zvol. What we're doing is we create a zvol, we export it over iSCSI to Windows machine. Windows is running NTFS, and the zvol that we create is like really, really huge. Sparse zvol, like I don't know, it's like 32 terabytes or something, and then the Windows machine just writes maybe a couple of gigabytes to it. So it's really big and really sparse. So we have huge ranges where there aren't actually pointers here. This is just like the pointers don't exist. The block pointers are just all zeros. Maybe there's one here that has some data. So when we do the ZFS send, when we do this incremental ZFS send, we know, okay, this block is before 10, so I don't need to send it. I don't need to send 17. I need to send 15. I need to send 17. But the annoying thing is, I also need to send these ones, these 0 ranges, because in the future, because if I were to zero out part of this file, then what would happen is, like, if I had this old block that was born at time 5, and if I wrote all zeros onto that and it compressed away to nothing, or if I did like a trim operation on it, then this block pointer would be a 0, just like these other ones that have always been 0. So I can't tell them apart. So in this case, like I have to tell the other side, hey, you need to zero out this range because before there was data there. Because of that, I have to always send these records to the other side telling it, hey, you need to free this range of the file whenever I see block pointers that are all 0. So there's kind of two problems. There's a bunch of related problems here. There's like the fundamental problem of like, okay, I'm telling them to do a lot of work that is unnecessary, right? There could be a lot of free ranges that gets a lot of records that I need to send. And then when we receive them, we have to process that. This creates unnecessary work. There's also a bunch of compounding issues where actually doing the free of that range had some really awful performance characteristics that were not fundamental to the problem, but they were like the algorithms just sucked. We made those improvements too, so that when you do have to send this free record, the performance is not nearly as bad as it used to be. But we also wanted to not have to even send these in the common case, because it's like we saw cases where it's like half of the records were free records because there were so many free chunks, and all of them were unnecessary to send. Like it's just that those ranges had always been free, so the other side already knows that they're free. So the fix here is that we now keep track of, so we call these zeroed out things holes. It's like a hole in the file where there is no data there. If you read from it, then we just fill your buffer with zeros. Right? This is how like sparse files are implemented, if you're familiar with that. So the solution is that when we create a hole, we actually record the time that we created the hole in the block pointer. So in this case where we had the block born at time 5, and we zero it out in the block pointer. So before it said, birth time is 5, and here's the checksum, and here's where this is actually stored on disk. When we zero it out, we zero out just the location on disk and the checksum and all that stuff, but we keep the birth time. So we'll know, we don't keep the birth time. We update the birth time to the time that it was zeroed out. So maybe that happened at time 19. So it'll say, so we'll know from this block pointer, this block pointer was zeroed out at time 19. So now when we do the ZFS send, we can look at this birth time and see, oh, this block was zeroed out after time 10, so I need to tell the other side to free it. But these ones were not zeroed out since time 10, so I don't need to tell the other side anything about it. And then, the next time I do a send, say at time 25, we'll see, oh, this is zeroed out at time 19. It was before 20, so I don't need to tell the other side anything about it. So we don't have these permanent records that are just permanently occurring every time we have to do a send. Any questions about that? So this, combined with the other things that I kind of glossed over, really provides a big performance improvement in terms of CPU usage, primarily when you're doing a ZFS receive of zvols, typically. But it applies to any kind of sparse files. So if you have VMDK files in file systems or disk images that you're using, those are also typically sparse files. Cool. Okay. So then I can talk a little bit about some work in progress. Cool. Do people have any questions? I have a bunch of stuff to talk about, random things to talk about that kind of continue along this laundry list format. But if people have specific questions or things that you want to hear about, then just jump in.
So a lot of the changes, we were talking about those new sysctls for controlling the depth of queues and stuff, they don't fall into a category where there would be a feature flag, right? There's no change to the
that's right.
format. Is there some way of tracking what version of ZFS I have, whether I have that feature or not?
Yeah.
Good.
Yes, you can simply do a zpool get all on your pool, and at the very end you will see all supported features.
That's feature flags, though.
I have a feature flag, but all the other changes that aren't changes beyond this format, but there's a feature flag.
So let me ask you this question: when I make an enhancement to the IP stack that improves the performance or changes the retry algorithm, how would you tell if that's present or not? How would you tell if that change is present in your in some given machine or not?
Whatever version of previous
Yeah.
A lot of it depends, actually.
Yeah. A lot of the times somebody will have a bike shed and then a tunable will be exposed.
Yeah, usually it's
Turns on and
tunable.
off. There'll be something in sysnet, inet, whatever.
But yeah,
so there you go. You look at the tunable.
Yeah, it's in FreeBSD 9.0 and 9.1 were both v28, but 9.1 had support for the verbose flag, so that when you're doing a ZFS send, so it would give you progress indication.
Yeah.
And when I was writing a script, there was no way I could tell easily whether I had that feature or not.
Yeah.
It's it exists in 8.3 and 9.1, but not in 8.2 and 9.0.
Yeah, I think this is really, this is a generic problem of any software. If I'm using tar and we add some new flag to tar, how do I tell if that new flag exists or not, right? You'd probably run tar-v and it would tell you what version it is, and then you'd say, oh, I know that version's greater than this, have it. So you'd do the same thing, right? You'd be like, what version of FreeBSD is it? Oh, it's 9.1. I know that 9.1 and later have this flag, so I'm going to use it.
I think that you can do this like it's tar, because there is this OpenZFS as central, and then several satellites import the features, and they don't do it at the same chronological order at the very same time.
So you have to have this.
Simply have you cannot have an incrementing ZFS version number for features or something. It's not possible.
You have to have this table separately for FreeBSD, Lumos, Linux, etc. Right?
How's the one central repository coming along?
It's coming. I have a slide. I can tell you about this.
It was a slide that was up actually.
Yeah. No, it was not. This slide is just well, yeah. Oh, I recreated this information. I knew I had done that before. Well, this expands on that a little bit. So for those who aren't familiar with this OpenZFS repo, the idea here is that the problem that we're trying to solve is that right now the status quo is that changes that are made in Illumos are pulled down into FreeBSD and Linux, but it's pretty rare that changes made in FreeBSD or Linux are upstreamed into Illumos. So it's very common that like a change would be fixed in both Linux and FreeBSD independently, and resulting in duplicated work. So the goal is to create a repository that would be upstream of Linux, FreeBSD, and Illumos, that would contain all the ZFS source code that's truly platform independent, and it would be easier to test and integrate into this workspace, into this code base. It would be easier to test because we would make all of the code able to be tested in userland. So you'd be able to, userland provides a pretty good sandbox. So we would be able to know that, if it runs in userland on Linux, then it will also run in userland on Solaris or FreeBSD or whatever. So that way, like you will be able to do all your testing on whatever your platform of choice is without having to muck with another platform. The steps to actually doing this are listed here. So we've started working on this at Delphix. We will definitely need help with this. These are kind of the main steps that we want to do before kind of declaring this at least as ready for like beta testing. So the first thing is actually like copy the code into a new repository. It turns out this is actually a giant pain in the ass if you want to preserve the commit history. But a weekend mucking with Git resulted in a script that would actually do this. So that part is done. The next part is to actually create makefiles or autoconf setup to be able to actually build all the userland components on the different platforms. So we started on this, and one of my coworkers promises me that he'll have it working by the time I get back. So we'll see. I'm not holding my breath, but if there are other folks that are familiar with, like, I don't really know anything. I mean, I know how to modify makefiles when they're already there, but I've never really done like cross-platform makefiles or done anything with autoconf. So my coworker has done at least a little bit of stuff with automake. If there are other people who are familiar with this and can help out, that would be great. So just kind of a summary of like the components that we're talking about building are just the userland ones. So libzfs, libzequal, ztest, the ZFS and zpool command line tools, not the kernel stuff. So the makefile setup hopefully will be relatively simple. So to enable testing in userland, we can test some stuff in userland today, like using ztest, but the code that it tests is pretty limited. For example, it doesn't test libzfs or the ZFS command line tools or ZFS send and receive. So to fix that, I created this ZFS daemon. Basically, the ZFS daemon, it uses libzpool and it also implements ioctls. So that basically when you run ZFS, the ZFS command line tool, instead of talking to the kernel, it can talk to this ZFS daemon and tell it like, hey, create this file system, set this property, do this ZFS send operation. And then the daemon and the ZFS process communicate using a socket. So everything that the kernel normally is able to do to processes is done by having the ZFS daemon make requests to the ZFS process. So, for example, when you do an ioctl, the kernel needs to like copy data from the user address space into the kernel. So with the ZFS daemon, it sends a message across the socket that says, "Please send me the data that's in your address space at this address." And then the ZFS process sends the data back over the socket. Questions about that? So the point of this is both to be able to kind of dynamically like fool around with this by running the ZFS tool, command line tool, but also to make the test suite actually run against the userland implementation, the ZFS daemon. So the test suite I'm talking about here is the test runner test suite, which is in Lumos. It has all the tests that were in the STF test suite. So there's like, I don't know, 1,000 or so tests that cover like most all the aspects of ZFS. The main impediment to getting this working is that obviously a lot of these tests depend on like mounting file systems and creating files in them. So all that depends on the ZPL, which will not be part of the OpenZFS repo, at least initially. So we'll need to create some kind of replacement for that. Hopefully we can get away with something that just kind of like emulates what the DD command does. So that we'll be able to like, have like a switch statement in the shell scripts that implement the test suite that say like, oh, if I'm running against the kernel, then run DD with these arguments. If I'm running against ZFSD, run like ZFS DD, specify the name of the file system, the object number that I want to modify, the offset that I want to change there, etc. So we've kind of, in terms of progress, we're like, this part is done, this part is like a quarter done, this part is like 75% done, and the test suite is like 5% done. Any questions about this? Yeah.
We have currently a project named ZFSD.
Yeah. So we might have to duke it out.
Find the way out of this collision.
You should call yours ZPoolD, because it is really dealing with pools.
Pool management diamonds.
Yeah.
Z-fault or something.
Yeah. Or I'm fine with changing the name of this too. This was just like, the first idea I came up with.
First
So
name that had something to do with ZFS.
yeah. So I'm not opposed to changing this name either. Somebody has to come up with a better name. That's all, or at least an acceptable name.
Z-test-D or something.
Yeah. Yeah. Cool. Other questions or things that people would like me to talk about before I just ramble on with my random list?
Is offline deduplication on the roadmap?
No. Yeah, offline dedupe. I think it would be pretty tricky to integrate with the way that ZFS dedupe and snapshots and stuff work today. Yeah. Sorry.
What's your use case for that?
The use case which is, I know on this space, the ZFS debug tool says, oh look, you have 50% duplication at this point. Let's enable deduplication.
Yeah.
Is even do deduplication in line with, like, ZFS, but you can't have enough room to have a copy of everything.
Mm-hmm.
But being able to do it incrementally kind of nice. And often I find you set up a big ZFS volume and it's not getting much traffic, but it is getting a lot of space used. And then you find after it's been deployed for a year that actually probably should have been able to dedupe a year ago. And having something that the disk's idle a lot of the time, but you're dumping a lot of stuff on it, being able to go through and just, when there's spare capacity, update things, do the dedupe thing would be good. That's the thing people keep asking me when it's coming.
Yeah. I mean, the answer is probably never. Like, to a first approximation, at least. I don't know of anybody who's working on it. Did I see a question?
Do you have any plans on writing a ZFS internals book?
No. However, the new edition of Kirk's FreeBSD internals book does have a pretty substantial chapter on ZFS. I've been working with him on that. So I think that's like, it's not a whole book, it's like 30 pages or something like that. But that's going to be coming out this summer, and that'll definitely be like a good first primer. I don't really have the time or inclination. Like, I wrote the paper for this conference and was reminded that, like, wow, writing is really hard. Yeah, that kind of reinforced my feeling that I don't want to write a ZFS book. But if somebody else would like to write a ZFS book, I'd be happy to work with them.
No, you should totally do it.
Not it.
Writing a book is one of the most satisfying things you can do.
Shush.
I don't doubt it would be satisfying. I just think it would be very difficult and both difficult and time consuming, and not very financially rewarding.
That's made me rich. As you can see, I flew around my private jet.
Yeah. So, yes. Sorry. I would love to see a ZFS book.
What about something like offline defragmentation? Like actually export the pool and then defragment it?
Yeah, that's like BP rewrite, but a little bit easier because it's offline. I don't know of anyone working on that. It's probably doable, especially if you're just doing defragmentation, then you don't have to worry about like block size changes. One of the challenges with a full BP rewrite solution, are the two big challenges are, one, you're doing it while everything is live, and two, the sizes of blocks can change. So, and that size is taken into account in many, many different places. So, if you didn't have those two constraints, then it would be a lot easier. Essentially, you're just saying like, all right, import the pool, read all of the blocks, write them out to other places, keep a giant hash table from the old location to the new location, so that when I encounter the same block pointer in a later snapshot, then I look it up in this hash table and use the changed the new block pointer from the hash table. I think that is relatively doable, but nobody's
But not on the roadmap.
not that I know of. Yeah. But like, if somebody wants to do that and has the the manpower, then I'd be happy to work with them on that. Other questions? Do you want me to just go on, tell you about some more stuff, or are you guys tired?
Keep going.
Okay.
You can stop.
Ever.
You can never leave.
You can never leave. It's under California.
Dante's presentation.
Oh my God. The horror.
So next, I can talk about some works in progress that we're doing at Delphix. Some of these you've probably heard of before if you've seen any of my previous talks. So I apologize that we're still working on them and these are not done yet. The first one and perhaps oldest one that you've probably heard of is resumable ZFS send. This is the idea of if I'm in the middle of a ZFS send and the network dies or one of the machines reboots, currently you have to restart that send from the very beginning. So you're redoing a lot of work. The fix here is basically to remember, to rely on the fact that we're sending the data in a particular order. And so when we're receiving it, we can remember what point we've gotten to and then restart the send from that point. So the way this will work is when you're doing the receive, it'll be keeping track of that, how far it's gotten in a ZFS property. And then you'll basically get that property. It'll give you a string that you'll pass in to ZFS send. So you do like ZFS send, -i, incremental, blah, 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 blah. And then there'll be some additional flags provided from the receiving side's property. That'll basically be like encoding of what point it had received up to. Any questions about that? So the next one is a new one that you guys probably haven't heard of, which is good. We just started working on this. So the problem that we're trying to solve here is avoid having to run chown on every file in a file system. So we have this problem at Delphix where we have a file system that has like all the files for a given database, and it needs to be exported over NFS to different machines, and a different user on each machine might need to access it. So it's only exported to one machine at a time, but we need to change all the files ownership to be whatever user is going to be accessing it there. So far, this hasn't been too big of a problem because usually databases are not comprised of a large number of files. It's a small number of big files. But as we're expanding out into other use cases like application data and like the binaries that are associated with the database and the application that's using the database, we've seen that this can actually be like the longest part of provisioning the database and all of its applications. Basically, we're going to implement a ZFS property that says like override the owner of all the files in this file system to be this UID. And so this will be like implemented in the ZPL. It'll just check this and override the owner of the file, so it appears to be this person. So this is kind of like if you ever used NFS on the Mac, you've kind of seen a similar thing in action, but implemented totally differently. So like on the Mac, when you do NFS mount, by default, it makes all the files appear to be owned by you, regardless of what they're owned by on the actual remote server. So this is implemented on the NFS client, but most NFS clients don't have this capability. So this is kind of implementing a similar thing, but at the server level. Device removal, we've also been talking about this. We've been talking about maybe doing this for a while, but I think that this is actually getting on the roadmap for us for this year. So device removal is one of the things that the mythical BP rewrite was going to provide. We're not implementing this by doing BP rewrite. Essentially, what we'll be doing is creating like a indirect VDEV. So, like if you have a bunch of devices, and let's say this one just has like some small bits filled in. This is VDEV ID 1, 2, 3. Basically, we'll create, we won't do exactly this, but you can think of it as essentially like creating a file, a big sparse file that holds all the data of this VDEV, and that file will be written out in the other devices. So like this, this might move somewhere else. So whenever, essentially the file provides this mapping from the offset in VDEV ID 1 to the new offset in its new location. So by doing this additional layer of indirection, we don't have to go change all of the existing block pointers. And then we're going to do some optimization so we don't actually have to use a file. We'll store this mapping like in a more efficient way. But that's the main idea. So this will allow you to like remove this device. It would also allow you to like shrink a device. If this device is like from a LUN, from a SAN, you could give the storage back by saying, okay, any offsets after this point are stored in this other file rather than in this VDEV. Cool. All right, so here's the next one, channel programs, is something that we talked about at the ZFS Developer Summit in November. And we actually started prototyping it, well, not just prototyping, implementing it at the hackathon that was associated with the Developer Summit. The idea here is to change the way that userland communicates with the kernel for doing ZFS administrative operations. So this addresses a bunch of different problems. One that is maybe near and dear to people doing the ports to FreeBSD and Linux is that in FreeBSD and Linux, I know you try to maintain user kernel, like the kernel interface is supposed to be static and not changed. So this is not the case on Illumos. On Illumos, the interface is libc, or whatever the libraries are. Because we install the kernel and the libraries all as one package. So you've had to like jump through a bunch of hoops to try and provide this backwards compatibility in FreeBSD. Channel programs, with channel programs, we would be able to basically, there would only be like one ioctl, which would be like execute this channel program. As new channel programs are added, then those would be, as new functionality is added, those would be like new primitives that channel programs could execute. Or as new arguments are added, those would be like new arguments to functions in the channel program that could be, we could provide defaults to implement the backwards compatible stuff pretty easily. But the overall idea here is that userland would be able to send down a little program written in Lua, which is a scripting language, that would be very sandboxed. So it would only be able to do primitives that we expose. So the primitives would be things like create a snapshot with this name, or iterate over all of the children of this file system. This will allow us to create compound operations much more easily. So today there's several kind of compound operations that are implemented in the kernel and others that are implemented like in user space. So for example, if you do ZFS destroy -r of a snapshot, it destroys that snapshot and all the snapshots beneath it. That's basically a compound operation implemented in the kernel. So userland creates the list of all the snapshots that need to be destroyed, sends that list down to the kernel, and then the kernel deletes all of those snapshots. If you do a ZFS destroy -r of a file system, it destroys the file system and all the file systems and snapshots beneath it. But that's implemented as a combination of like userland compound and kernel compound operations. So like in userland, it goes and iterates over the file systems, and for each file system, it does one ioctl down to the kernel saying, please delete this file system. So the atomicity of all of this is very poorly defined, right? If you're on the command prompt and you do ZFS destroy -r, you don't know whether it's going to be one operation or many operations until you type like, okay, it was a snapshot versus it was a file system. With this channel programs implementation, we'll be able to send down much richer instructions down to the kernel so that much more complicated operations will be able to be atomic. There's a bunch of kind of corner cases associated with the existing compound operations. So for example, when you do this compound destroy operation where you're destroying a bunch of snapshots with one ioctyl down to the kernel, userland has to create the list of snapshots and then send that down to the kernel. So if something changed between the time that it gathered the list and when it sent it down to the kernel, then the operation could fail or not do what you intended. So like if you tell ZFS to destroy all of the snapshots of this file system, userland gathers the list of all of them, and then if some other thread creates a new snapshot, then when we send the list, the first thread doesn't know that the new snapshot has been created. So we'll delete all the snapshots except for that one.
And the destruction of the file system will fail because
it's dependent on that, right? So by being able to bundle like the iteration and deletion, all that stuff into one channel program, it'll all be done atomically down in the kernel with all the right locks held, so nobody else can be concurrently making changes. Initially, because you can write like an arbitrary program in Lua, you could theoretically like cause the kernel to hang forever or like do something weird. Initially, at least, basically, ordinary users will only be able to run channel programs that the kernel has already fed down to the kernel. Basically they'll only be able to run channel programs that root has already fed down to the kernel or that have been baked into the compiled into the kernel. Ordinary users can do ZFS operations if they've been given permission based on like ZFS allow, and only root will be able to actually execute send down arbitrary channel programs to the kernel. This is just for safety. Cool. Questions about channel programs? If you're interested in that, there's a bunch of slides on the OpenZFS website and a video of a presentation that my coworkers did on this at the OpenZFS Developer Summit. I already mentioned the platform independent repo. All right, cool. So I think this is the last. Yeah, those are kind of. So the last thing that I was going to mention is large block support. So we've been talking about this for a while. So today, OpenZFS supports blocks, variable block sizes from 512 bytes up to 128 kilobytes. Solaris 11 supports blocks up to 1 megabyte. The main reason for implementing larger blocks is for better performance on with like streaming workloads. Obviously, this isn't going to help like random reads and writes on your small files or on like a database file. But these larger blocks are especially helpful if you are using like RAID-Z, especially if you're using RAID-Z with wide stripes, because essentially if you end up having to, even if each thread is like reading and writing one big file in order, that can still devolve into what essentially looks like a random reads, a workload of random reads. If you have many threads doing this to different files, like at a video server, or if you need to do like a zpool scrub and the file layout on disk wasn't totally perfect, then these can devolve into essentially random reads. So by reducing the number of blocks, by increasing the block size, we reduce the total number of blocks, and thus like the total number of seeks that we have to do to read all of it. So I think that especially on scrubs, this really limits the worst case performance of a scrub, which can be very bad with large RAID Z stripes. Because the RAID Z, essentially like you might have a giant pool with like, 30, like say 30 4 terabyte drives. That's like a lot of data. If that's all in 128K blocks and you're using, let's say you're using really wide stripes that are 10 disks wide, it means your pool can only really do like the IOPS of 3 disks, so maybe like 300 IOPS. And if you have a lot of blocks to read, that can take a really long time. So by going from 128K to like 1 meg, it's an eighth as many blocks to read. We could also easily increase this further to like 8 meg or more.
Yeah, that was my question. Was the 1 meg just arbitrary, or is there an implementation currently?
The 1 meg is just arbitrary. I've actually been testing this with up to 8 megabytes. It seems to work just fine.
That's like exactly my use case. We have a server with 34 terabyte hard drives. We were looking at doing 3 sets of 10, but we went with 5 sets of 6 instead because the IOPS.
Yeah, to get a little bit better IOPS. Yeah.
I think our smallest file is like 600 megabytes.
Mm-hmm.
It's all giant video files.
Yeah. So that's exactly the use case that I was thinking about when working on this.
Would it make a difference if you had like virtual machine images, which tend to be large? Although I don't know if you want.
You probably wouldn't want to do this for VM images because they tend to have a lot of random access.
But specifically, a larger block size would mean less memory usage on deduplication, right? If
the blocks were identical, which would be highly unlikely.
It's less likely to get.
Yeah. I mean, if you want to dedupe virtual machine images, you typically are going to have to set the record size to be the same as the file system that's running on top of its block size, which is like usually 4K. Right? So yeah, this wouldn't help that case. So the main philosophy I use when implementing this is that we should keep using 128K block sizes for everything unless it's explicitly requested that we use more. So the concern is that using larger blocks can have a big impact on like the memory subsystem. We're still using KMM caches to do all of this. So it's going to result in like really big KMM slabs. And it might be fine, but it might not be fine depending on your operating system. Like I know Linux has a lot of problems even with just 128K blocks today. So I didn't want to make it so that like people would accidentally get into a case where they're using larger blocks without explicitly turning it on. So in terms of like implementation, I changed the SPA. So the SPA max block size is like the pound define that defines the maximum size of blocks. I changed that to the larger size, added a new macro for the old block size, and basically to first approximation, I changed every instance of SPA max block size to SPA old max block size. And only things that actually really needed to know what the maximum block size are, use SPA max block size, the new 1 megabyte or larger size. So typically this is like when we're creating a file and nobody specified the block size, we default to using the maximum, but that's going to be old max block size, so it's still going to be 128K. So each data set keeps track of if it has ever had its record size set above 128K, then it's basically, we mark that as like, a large block data set. And when we do that, we increment the SPA feature rough count. So basically the feature rough count is going to be however many file systems have or have ever had the large block size enabled on them. So if you delete all the file systems that ever had large blocks, then the feature rough count will go to 0, which means that the feature will no longer be active. And so you'll be able to export the pool and then open it on a system that doesn't understand large blocks. This is kind of in contrast to like the rough counting, the feature tracking scheme that I talked about for embedded block pointers, where like as soon as you enable the embedded blocks feature, it's activated and it's always active forever. Yeah. So you can never, that pool will never be able to be used on older software, which is like, that's how it always was with the old like feature flags method. Like once you upgrade, it's just like, that's it, you're done. So there are some features that are like that, but when we could, I tried to make it more flexible. So then, there are a bunch of dataset specific use cases, dataset specific cases where it was using SPA max block size. And I changed those to use a function that returns either 128K or the larger maximum based on if that data set has been enabled for large blocks. So one cool thing that I haven't yet done, this is the only part that I haven't actually finished yet, is the send and receive support. So because this would change the send stream format, what I would like to do is set this up so that if you don't specify a new flag to ZFS send, then it will actually generate a send stream that's compatible with old software. So it will like reduce all the blocks down to 128K and cap all the block sizes. I think that this should just work, which will be pretty nice. We did a similar thing with embedded block pointers. So for embedded blocks, we wanted to be able to keep the space savings that we have on disk when we do the ZFS send. So this is in contrast to normal compression. So normal compression, like when you do a ZFS send, we uncompress the data and then send the uncompressed data over the wire, which is kind of too bad. With embedded blocks, we actually have a new record type in the send stream that says, here's an embedded block, here's the compressed data for it. But that will only be used if you specify a new flag. So if you don't specify that new flag to ZFS send, then it'll just reinflate the embedded block, and it'll be able to, and so you'll be able to receive the send stream on old software as well. Cool. So the last note is that even though we're probably using the same on-disk layout for these new blocks as what Oracle is using in Solaris 11, this won't really be on-disk format compatible just because we keep track of our on-disk format separately, right? Like we use feature flags versus Oracle just says, oh, it's version 32 or whatever. It should be possible to create like an offline tool that would like convert between the two on-disk version specifications. So like basically like take Oracle version 32 pool or whatever, read all the, do like a scrub essentially, read all the metadata and determine that like, okay, it's version 32 and they're using big blocks, but they didn't use any of the other stuff that's related to version 32 that we don't understand. Like, they're not using encryption, for example, and then basically force the pool to change its version number to, the feature flags version, and then mark the feature flag for large blocks as being enabled, and mark all the file systems, set the ref count, all that kind of stuff.
So a tool to rescue people that are stuck in order.
Yeah, exactly. Assuming that they're only stuck because they're using large blocks. But yeah. So that's basically all that I have for this presentation. I guess one final thing I'll mention is there's the macOS 10 port has been revived by Jürgen Lundman, and he just launched a new website for it today, which is, I think, OpenZFS on macOSX.org.
Wow.
It's quite a, it's like O3Z or something like that, which is like Open ZFS on, I don't know. I'll remember it and put it in my slides for tomorrow. But he's actually based in Japan, and he's going to be at the conference tomorrow. So if you're curious about ZFS on macOS 10, then search him out. I can point him out to you. Yeah.
What's the file system and snapshot count limits?
So this actually, this has been in the works for a long time, but I just got a new code review from him, so hopefully they'll be able to work on it some more. This is from Jerry Jelinek been working on this. He's at Nexenta. He's at Joyent. So Joyent's been implementing this. The idea is, Joyent really heavily uses Solaris or Illumos zones. Zones are like FreeBSD jails, same kind of idea, just like a little bit richer. So you can delegate a ZFS file system to a particular zone. And then the administrator of that zone can create file systems, set properties, create snapshots of the file system that's been delegated to their zone. But if you let them kind of go totally crazy, then they could theoretically create millions of snapshots impacting performance of the whole system.
This is like a quota, like how many snapshots?
Yeah, it's just like a quota of how many snapshots can you have, and how many file systems can you have. Yeah. And it only applies to use within a zone.
Well, that works with FreeBSD jails as well.
Yeah. So it should work the same on FreeBSD.
Does it work in the context of delegated admin, topbles, stuff?
If you
just did ZFS allow on the
Yeah. If you do, I think that I'm pretty sure it also applies with ZFS. If you use ZFS allow to allow people to do that rather than using zones or jails.
Yeah, because we're doing a little of that on some of our machines.
Oh yeah.
Basically trust our users, but
yeah,
we're letting them muck with NFS exports and conceivably make snapshots.
Mm-hmm.
Yeah, I just added the instructions to the handbook on how to do ZFS replication without needing root by delegating to a user.
By ZFS allow. Cool. That's cool. ZFS allow is it's really cool and really neat, but not very widely used. I think mainly because the idea of a multi-user machine is kind of disappearing, or at least that's not where a lot of new deployments are.
We're using a test front end to a test cluster, so giving people the ability to export stuff, and then the delegated root thing.
Mm-hmm.
Which I don't know if it's a standard feature or just a topple thing, but in FreeBSD, but you can make a particular, whoever mounted the volume be the super user on the volume.
Oh, cool.
So you can do a FreeBSD install with all the permissions correct so that you can net with something.
Yeah, that's cool.
One of our use cases is, so we have an unprivileged user that runs a script, and it uses like ZFS user space to track all our different customers and how much space they're using so we can charge them for it.
Oh, cool.
And so having that done by an unprivileged user that can't even see what files they're using, they just get the stats from ZFS. And, Bob is using 2 terabytes of space.
Cool.
So charging 20 cents a gig.
Cool. That's like 2 rarely used features that I implemented for ZFS used together. ZFS allow and ZFS user space. Yeah. So glad to see them being used.
That's critical to our business model.
Cool. Other questions? I don't really have any more.
One other one that I don't understand or recognize, multi-modifier protection.
Nobody's actually working on that. As you can see, there's no name by it. The idea is, people do like active passive failover using ZFS, where like you have 2 computers both attached to the same storage. When one computer dies, then the other one will import its storage pool. A lot of these schemes are implemented kind of poorly, so that sometimes it decides to do a failover before the first machine is actually dead, resulting in the pool being imported on both machines simultaneously and then loss of all of your data. So the idea here is to implement something like at the ZFS level that would actually be able to prevent this kind of thing. So the basic algorithm is like, every so often I write something to the disk that says like, hey, like this disk is I'm still using this disk. And then when you do a zpool import, like even if you do a force import, it will like read from the disk and see like when the last use was, and then like wait for, whatever the timeout is for the other guy to write. So,
solve a lot of problems with the hash script for running ZFS on 2 machines.
Yeah, like any kind of HA solution like needs to be implemented very carefully, and most of them are not. So this is basically a way of saying like we're going to implement it very carefully in ZFS so that you cannot shoot yourself in the foot. But there's like a design for this out, but as far as I know, nobody is actually working on it. The design originally came from like the Luster guys wanted to use this. Cool. Any other questions?
I just have one more. We've had use cases where the pool gets a little too full, and we have this directory full of very large log files. We go to delete 35 gig log files, and it takes an hour. Why does it take so long just to RM a file?
That's a good question. Do you only see it being slow when the pool is very full?
Usually. I don't normally notice a problem when it's not very full, but it does seem, even when it's not very full, it can take like 5 seconds to RM one file.
Yeah, and the files, you said it was like many gigabytes.
Yes.
So this is just a guess, but when the pool gets very full, then we have to be very careful about how much changes we allow, so that we don't run the pool totally out of space. Because if we actually allocate all the space in the pool, then like the pool is essentially read-only.
Right, you can't make a change.
Yeah, because like ZFS has to write everything into new previously unallocated space. If there's no unallocated space, then you can't make any changes. So we do some pretty conservative estimates of how much space could possibly be used. So like when you do a write, even if you're writing, say, like 1 megabyte, we might have to make a conservative estimate that might actually result in like 10 megabytes changed on disk, because maybe you set the copies property to 3, and maybe you're on a RAID Z, and maybe the block size is really small, and maybe, like all these like terrible what if scenarios.
I think if the tools were that full, but like if it's got 20 gigs of free space, it shouldn't take long to delete.
Yeah, if it's got gigs of free space, then that should not come into play.
It hasn't happened that recently, so it might have been 9.1, so that's like pre-feature flag. So
yeah.
Could be a solved problem.
I'm not sure. I don't recall any work in this area that would have fixed it.
Well, there's some of the stuff for fragmented pool plugins a little.
Yeah. There's definitely stuff that would make it like a bit better, but I don't know of any like massive improvements there.
Like I wondered if it was waiting to actually free stuff, and there's something like async destroy, but.
Yeah, it's not. It doesn't really work that way. I mean, my concern was that when you delete a file, a big file, we chunk up the destroy, or we chunk up the removal. So like first we essentially what we do is like truncate the file to here, and then we truncate the file to here, and then we truncate the file to here, right? So that we don't have to do too big of an operation all at once. So my thought was that like each of these truncate operations, like it could theoretically also result in more space being used on disk, at least temporarily as we write out the new indirect blocks. So it could be that you're in some really horrible case where like every time we do this, we have to wait for another transaction group. So because the way that like if we have,
do you know how big those chunks usually are?
I think that they're like, I want to say like it's in the hundreds of megabytes range.
But if it's a 50 gigabyte file,
it's still a lot of chunks, right? So typically, it's able to like delete a lot of chunks in one transaction group. So,
it's highly fragmented and very low on space. I can see.
Yeah, then it could be worse. I mean, there is, if you're talking about like a file that's like a lot of gigabytes, there is a fair amount of metadata that would need to be read in. I mean, if you have if you're using like 128K block size, it shouldn't be that bad. Let's see. We'll do some math. Like if it's 32 gigabytes, kilobytes, megabytes, gigabytes, whoops. And you're using 128 kilobyte. So you would have like 200,000 block pointers, and there's 128 block pointers. So you'd have to read 2,000 blocks, approximately. So,
and because it's a log file, it's grown over time, so
it's scattered.
All over that.
So, but I mean, even if you're doing like only 100 IOPS, that's still only 20 seconds. And you said it was taking several minutes, right? So, it shouldn't be that.
I think it was waiting for a transaction.
Yeah, that seems more likely.
What's that middle transaction stage?
Mm-hmm.
Like, where it'll accept new stuff?
Yeah, it's waiting for it to quiesce.
Yes. I don't know how you...
All right, cool.
Okay, I hope you guys enjoyed that presentation. A lot of good information there. I know you couldn't get it from a better source.
Yeah,
That's just
it wasn't quite as good as being in the room. Being in the room was awesome, but that's about as close as you're going to get.
But I don't know. You missed a 16-hour or more flight, depending on where you're coming from.
Mine was 13 hours, and it was worth the 13 hours just for that. Not to mention all the other great stuff at BSDCon. But
true.
Yes, getting it from here is a lot less of a hassle compared to the flight.
Yes, definitely. But now that we're back, of course, we want to mention our other sponsor for the week, of course, IX Systems. And, all the cool stuff they've been doing. We don't have any current news this week because this is a pre-recorded episode. But, of course, we want to mention a couple things about this. First up, the address, ixsystems.com/BSD Now. Go there, fill out the information. They'll let you download a cool guide on purchasing a server for open source. You know, the top 10 things you need to know before you make that decision, what your vendor should be doing for you. And then, of course, the IX Systems guys can talk to you and customize anything you need done.
Yeah,
tell them this is what my needs are. This is what I'm running on the system, and then they'll, oh, okay, you need more processor, you need more RAM, or you need, you know, less of that, more of this, etc. And they'll build a custom solution to fit your very specific needs.
They can build very custom solutions, like the one I pulled up here from a couple of weeks ago. Megaport has it's actually 4 systems packed into 2 user of space. Each one has 6 10 gigabit Ethernet interfaces.
Dang.
So that's 24 10 gig cards in a 2U factory. It's like you can barely get that in a Switch.
Yep, that's really cool. And of course, considering we just did our presentation from Matthew about ZFS, the IX guys, I mean, ZFS, they are all over that. FreeNAS, you know, pretty much lives on ZFS. PCBSD, that's what we do. We're another IX project. So,
and they have a lot of people,
ZFS experts.
Yeah, they have a lot of people that are actually developing actively on ZFS. Not to mention just building it into all their products.
I'd have to go do a head count how many kernel committers and source committers they actually employ now, but it's a fair number. A lot of them working on ZFS and controllers, drivers, etc. So,
well, yeah, that's the other thing.
Something needs to get done, they'll do it.
They have that relationship with LSI, and they actually are helping write the new 12 gigabyte per second SAS drivers as well.
Nice, nice.
And make sure those work really, really well on FreeBSD.
Definitely.
Because I forget, I think it was Zin, maybe somebody else at IX just committed the stuff to make ZVols work better when you're hosting Beehive virtual machines on ZFS on your FreeBSD system, which was something I was wanting. So it was really great to see IX make that happen for me.
Of course. So, you know, in addition to all the software work they do, they have some great hardware to choose from. Of course, the latest and greatest Intel processors all on board, everything from the FreeNAS Mini that'll sit underneath your desk at your feet to that massive server that Alan just showed.
Yeah, well, this one's actually small. It's only 2 U's. That's like,
oh, really? Okay, well, not that big.
It's about the size of 2 pizza boxes topped on top of each other. There you go. And they pack a lot of power in that, so you can imagine what they can pack on a pallet.
Definitely. Yeah. They can build some pretty wild rigs all the way down to the small ones. So anything you need, anything in between, they'll hook you up.
Whether you need 2 cores or 80, or, you know, 1 gigabit NIC or, you know, 24 10 gigabit NICs, they can make that happen.
Cool. And of course, with all the BSD expertise to back it up and make it hum the way it's supposed to.
Yes, that's the biggest thing. It's just when you buy the server, knowing that it's just going to work is so much peace of mind.
Very important.
You know. Years ago, I used to kind of piecemeal the servers together myself. Thought it was cheaper. When I actually compared it recently, it's like, IX is actually going to save me money. Not to mention save the little bit of hair remaining that I have.
Yeah, that time is so important. You don't get that back. Yeah. And I'd just rather have it plug in.
But I was actually just surprised at how close the prices were. It's like, wow, they're not charging me an arm and a leg to do all this crazy stuff they do for me.
So again, that URL, ixsystems.com/BSDNow. Let them know that we sent you. We'd appreciate that. We'll be back in just a moment with our feedback and questions for the week. Okay, first up on our feedback and questions for the week, we have a email here from Remy asking about FreeBSD's IPsec L2 TP VPN. So what's going on, Alan?
So actually, Remy wrote in a couple of weeks ago and asking a question about getting his VPN working. And he says, us mentioning on the show worked. The topic was picked up and a lot of debugging and kernel recompilation happened back and forth. And he managed to figure out what the problem was, and it turns out it might have actually been a bug related when you mix IPFW, IPsec, and NAT together. And there's actually a PR on it. And now he's upgraded to 10.0-stable, which is what will eventually become FreeBSD 10.1. And now his setup works.
Sweet.
He said he did have some issues with the upgrade, specifically with
Going to Unbound.
But he actually documented the process, so it's up on his website. And so if you need to do the same thing, you can check out his documentation there. And he also has a link to the topic over at the FreeBSD forum, which is now marked as solved and actually has the resolution included, which is very nice to make sure that now when someone stumbles across that on the forums, when they Google for the same problem, they will see the answer as well.
Nice.
That's one of the really nice things about the FreeBSD forums compared to a lot is they spend a lot of effort curating it so that if you stumble across a thread that's marked as solved, you can actually find out what the answer was.
Definitely. Well,
So
very cool.
I'm glad we could help.
Yeah, glad we could help there, Remy. Okay, next up from Darren, talking about BSDCan. He says, "Hi, guys. I'm in a bit of a pickle. I love the show and really want to meet you all at BSDCan. I live in Montreal, so I have no excuse as Ottawa is only 90 minutes away from me. However, I'm a little worried that the $200 to $300 weekend won't benefit me that much since I'm not a developer. You've inspired me to come, though, and I need to make this decision based on finance and taking a day or two off of vacation time. Hope this isn't a rant or a plea, but I suppose I still need a little reassuring that spending the money will be worth it to see you all. Hope this reaches you." Well, we did read it on the air, Darren. So, of course, this will be airing while we're at BSDCan. So I hope you made the decision to come. Yes. And I think we're out talking to you right now.
I think I replied to it in the thread. Okay. But yeah. BSDCan is more than half specifically for not developers. They have an entire track of sysadmin stuff, right? So if you're just using the stuff to make a server or whatever, there's a lot of great information. A lot of what BSDCan is about is getting the developers to meet the non-developers, the users, and find out what the users want, right?
Give feedback and stuff.
Oftentimes the developers are working on their problem, but they'd love to hear, oh, I'm having this problem, and they want to solve your problem for you. They just have to know what it is. And
plus, that face-to-face time, if you have a question or something that may have taken a long time to get kind of sorted out in email or IRC, getting a hold of the right person, I mean, you're literally going to be bumping into developers at BSDCan, and nothing's better than a couple minutes of FaceTime where you can express what it is you're looking at, what you're interested in, hopefully get a really good answer really fast.
Yeah.
I mean, never mind, there's going to be a ton of great talks to go sit in on, and like you said, the developer system administrator track is going to be fantastic.
Yep. There's also,
and of course, the social events are a lot of fun too.
And there's a hacker track, so if you're interested in like playing with Raspberry Pi and the BeagleBone and stuff like that, there's a whole bunch of stuff on that. And there's stuff on like IPv6 and whatever you're interested in. There's probably a couple of talks that you love. Plus the hallway track is amazing.
Yeah, maybe this is the excuse to get involved, though. Not as a developer. Maybe you want to start somewhere like documentation.
And they'll
have a doc sprint.
Yeah, every night at BSDCan, there's a doc sprint. So even if you know absolutely nothing about how the docs work, you come and we'll teach you and we'll get you started, and you'll be writing docs in no time.
There you go. Get your doc commit bit and be part of the project before you know it.
Exactly.
So yeah, we're hoping you come out, Darren, and looking forward to being out there next week.
Yep.
Okay, next up from Steve. He has a question about make.conf. He says, "Hello, sirs. Thanks for the show. It was nice to meet you at Tokyo Asia BSDCon this year."
Yes,
it was good to meet you, Steve.
Nice to meet you too.
Good to hear from you. So he says, "Sometimes in FreeBSD, I stumble upon a useful Etsy make.conf option that I haven't heard of before. Is there a complete reference to all current make.conf options? I've been hoping there would be." SD. Of course, he had to put that on there.
Yeah.
So we just discussed this a little bit beforehand, but there's a couple different things. So if you're building world stuff, it's going to be Etsy source.conf.
Yeah.
And there's a man page for that, which I think is pretty good about documenting all the various with or without flags you may want to use when you build the system.
There are some, I think almost all of them are covered in the man page, but there's also the comments in the actual make files in the root. But you shouldn't have to delve into those. Those comments are mostly there for making changes to the make file. So yeah, there's the man pages for make.conf and source.conf. Source.conf is specific to when you're compiling FreeBSD itself. With make.conf, that applies to anytime you're using the make command anywhere. So that's compiling any software. So there's not really an exhaustive list of the options because it's specific to different software. Although there are a lot of like generic or global options that apply to a lot of things, and those will be documented in the man page.
Sure. Yeah, if you look at the man page there is some stuff for building the kernel and building world and whatnot. But I suspect you're thinking like ports tree, and sometimes those flags can change, sometimes rather quickly.
Yeah, and some of them are specific to an individual application.
Yeah. One place, of course, to look is user ports MK. Take a look in that directory. You'll find a lot of make.conf flags that can be set.
The one I helped build was default-versions. And it's basically in make.conf you can say, whenever you need Perl, I prefer Perl 5.16 as opposed to 5.14 or whatever. I like PHP 5.4 instead of 5.5 or 5.6 instead of 5.5 or whatever.
So that requires a little bit more hunting for them. Yeah. And of course, sometimes individual ports will have specific options, which you may set in your make.conf.
Yeah,
like I've done that on a number of how we build PCBSD special flags and stuff.
Right, or like if you're installing Apache and you want to use the suexec module so that CGI scripts will run as the user that owns them, there's a value set for like the minimum user ID that's allowed to do that, so it'll never do it as root. Sure. And that's a make.conf variable that's like Apache _ blah, 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 blah. So to make it clear that's specific to Apache. And so ones like that will be not in the make.conf.
It'll be in the specific port that you want to build, which you can actually look on fresh ports for that too.
Yes,
you just bring up the port and look at the options below. That's your list right there. Well, cool. Well, hopefully we answered your question there, Steve. And again, it was good to see you in Tokyo. Yeah. So next up, question from Pascal about backup via OpenVPN. So what's he doing here, Alan?
He has apparently 2 OSs on his laptop. One's OpenBSD and one's Linux, and he wants to back them up to his home server. The program / script should run when I'm at home and get triggered when I connect to my home network via OpenVPN. He says, I know that one can trigger a program when you connect with your OpenVPN. Do you have any recommendations? That depends on a couple things. Obviously, Tarsnap is great, but that's going to back up to the internet rather than your home server. For home server, way back in the day, I used to use this one called Flex Backup, which is like a shell or Perl script, I forget which, that basically just makes a tar and uses the modified times on the file to make a new tar the next day or whatever, and manages all the backups. That's quite useful. And again, yes, you can trigger it with OpenVPN. And then I've used Bacula, but that's going to be overkill for backing up one machine.
Sure.
Since it almost doesn't require, but it's mostly set up for many machines.
Well, cool. I hope he answered your question there.
When it's OpenBSD and Linux, it's a little harder. If you were doing FreeBSD or PCBSD and you're using ZFS, then you can obviously replicate snapshots to a server or something. But something like dump or flex backup for creating tarballs.
Nice.
Is what I would recommend.
Cool. Okay, well, that's the end of our feedback and questions for this week. So, of course, we want to mention all of our tutorials will be posted in their entirety at bsdnow.tv. Send your questions, comments, show ideas, topics, or stories you want mentioned on the show to feedback at bsdnow.tv. That's the only place we monitor, so please send them there. If you've got something cool to talk about, would like to come on the show for an interview, shoot us an email, and TJ will be happy to schedule you.
Sure,
We'd love to have you on the show. Also, if you have tutorial requests, we'll be glad to show whatever the viewers want to see. This is a community program in that sense. So if there's something cool, a new feature, a tutorial you want to see on how to do foo on whatever BSD, let us know. We'll be happy to try and write one up. Sure. Of course, you can watch live Wednesdays at 2 p.m. Eastern, 1800 UTC. We'll be back next week with our regularly scheduled live show. Yep. So looking forward to seeing you guys then with, I'm sure, a lot of stories about how BSDCan went.
Plus, we have an awesome interview about running a BSD user group.
Nice. Okay, well, looking forward to the show next week then, Alan. So again, thanks for being with us this week. Hope you guys have a great week, and we'll see you soon.